Atacama Oases. It's not about what you see, it's about what you hear, so you can truly understand. Our goal is to reach 100,000 subscribers. Be one of our very first supporters.
Ever wondered what makes MRI machines tick with such insane precision? Or what's the secret sauce behind the world's most powerful magnets? And why are certain lasers now capable of performing such precise eye surgeries? The answer lies in a super rare element that makes up only a few parts per million of the Earth's crust. Meet holmium, the mysterious element with atomic number 67. This shiny, silvery element, only discovered in the late 19th century, is now a total cornerstone for some of the most critical tech we use every single day. So what's the story behind this element? How have scientists managed to harness its unique properties? And what makes it so incredibly important despite being so rare? So, what exactly is holmium anyway? It's a chemical element with the symbol Ho and atomic number 67, and it belongs to the lanthanide group known as the rare earth elements. It was discovered by the Swiss chemists Marc de la Fontaine and Jacques-Louis Sauret back in 1878, when they noticed some mysterious spectral lines in a sample of the mineral gadolinite. They named it holmium in honor of Stockholm, its Latin name being Holmia, where they actually did the analysis. This discovery went down at a time when spectral analysis was the go-to tool for hunting down new elements. So, where does holmium sit on the periodic table? It's the sixth element in the lanthanide series, sandwiched right between dysprosium and erbium. Holmium rocks a shiny, silvery look, and it's actually a relatively soft metal that you could cut with a knife. It's got an atomic weight of 164.93 grams per mole and a density of 8.79 grams per cubic centimeter. It also reacts slowly with hot water and oxidizes in dry air to form a protective layer. These properties make it totally stand out from other elements, as it's got a unique stability at room temperature. So why is holmium considered a rare element even though it actually exists in nature? Well, its concentration in the Earth's crust is barely 1.3 parts per million, which honestly makes it less abundant than gold. It's always found scattered in minerals like monazite, gadolinite, and fergusonite, and you'll never ever find it in its pure state out in the wild. Extracting it is a massive, labor-intensive mission because it's always mixed in with other rare earth elements that share such similar chemical properties. For instance, just to pull out a single kilogram of pure holmium, you've got to process tons and tons of raw ore. So how do we actually pull holmium out of its raw ores? It's a super complex process that kicks off by grinding the ore down and hitting it with heavy-duty acids to dissolve the minerals. After that, they use ion exchange to isolate the holmium from all the other elements. It's a precise, high-tech method that relies on the different rates at which the ions settle out. Once that's done, the holmium gets reduced using calcium at extreme temperatures, hitting up to 1400 degrees Celsius, to end up with pure metal that's 99.9% clean. This whole process has really evolved over the years to become way more efficient and relatively cheaper. So, what makes holmium the absolute MVP of the magnetic world? It boasts the highest magnetic moment of any naturally occurring element, meaning it can transform into an insanely powerful magnet when exposed to an external magnetic field. It's also famous for its super-sensitive Néel temperature, which sits at 132 Kelvin. That's where the magnetic atoms totally shift their arrangement. This unique trait makes it the go-to choice for building ultra-strong magnets used in high-precision gear that demands massive magnetic fields. For instance, holmium alloys are used to whip up magnets that hit power levels of several Teslas. One of the coolest things about holmium is how it's a game-changer for MRI machines. It's used to make superconducting magnetic coils. By adding just a dash of holmium to the alloys in those coils, the strength of the magnetic field gets a massive boost. Plus, it helps dial up the resolution of those medical scans because it allows for way better control over the magnetic gradient. This means doctors can spot super tiny, detailed structures inside the human body, helping them diagnose stuff with insane accuracy. Honestly, none of these medical breakthroughs would have been possible without the unique properties of holmium. So how does holmium actually work in lasers? There's this awesome piece of tech called the holmium YAG laser, where holmium is doped into a crystal made of yttrium, aluminum, and garnet. This laser kicks out a beam with a wavelength of 2.1 micrometers, which is absolutely perfect for medical stuff. Surgeons use this laser for super precise procedures, like breaking up kidney and bladder stones, because the beam slices through tissue with pinpoint accuracy and triggers instant blood clotting. It's also a total lifesaver in eye surgeries to fix certain issues, and even for treating prostate enlargement. It's genuinely revolutionizing modern surgery, thanks to how accurate and safe it is. Holmium also plays a massive role in the nuclear sector, where it's used to build control rods for nuclear reactors. Its isotopes, especially holmium-165, have this insane ability to absorb neutrons, which makes them absolutely perfect for keeping nuclear reactions under control. In these reactors, rods made from holmium alloys are used to dial in the fission rate and stop any runaway chain reactions from happening. This keeps the reactor super safe and stable, preventing it from overheating to dangerous levels. It's honestly a vital element for keeping nuclear energy safe and reliable. Holmium has also totally made its way into the world of optical communications. It's used in making fiber optic amplifiers, where it's doped into glass fibers to act as an amplifier for the light signals passing through. This lets data travel over way longer distances without needing the signal to be constantly boosted. Plus, holmium lasers are used in some space communication systems, acting as a transmitter for sending data between satellites and ground stations. These applications have made the internet and global comms so much faster and more efficient, all thanks to how this rare element nails the job of boosting signal quality. When it comes to optics, holmium is a total superstar. It's used to color glass and craft specialized optical filters. Holmium oxides give glass a really distinct yellow or pinkish-brown tint, and they're even used in welding goggles to keep eyes safe from those harsh, harmful rays. Plus, holmium filters are a must-have in high-precision optical gear like spectrometers and microscopes, where they help screen out specific wavelengths of light. These filters are absolute pros at letting only a super narrow band of light through, which helps scientists analyze materials with insane precision. It's honestly an indispensable part of so many scientific tools. Holmium is a total beast in metallurgy too. It's added to certain metal alloys to seriously level up their mechanical properties. Just adding tiny amounts of holmium to aluminum and magnesium alloys makes them way tougher and way more resistant to corrosion. It's also a go-to for cranking up the performance of alloys used in aerospace, basically the industries that need materials that are super lightweight but can still handle insane extreme conditions. These alloys end up in aircraft and rocket parts, helping them last longer and stay rock solid under pressure. It just goes to show how essential holmium is for high-precision industrial tech. So, what's the deal with the challenges of mining holmium economically? The cost of pulling it out is super high compared to the tiny amounts we actually get, which makes it one of the priciest rare earth elements out there. Plus, most of the rare earth mines are tucked away in just a few spots around the globe, which creates a total supply monopoly and messes with price stability. The prices of holmium get hit hard by political and economic shifts in the producing countries, pushing companies to scramble for more efficient ways to extract it and recycle it. But with the demand for cutting-edge tech skyrocketing, the need for holmium just keeps climbing and climbing. To tackle these scarcity challenges, intense efforts have kicked off in the world of recycling holmium from e-waste and old-school tech. We're talking about pulling holmium right out of legacy magnetic coils and the guts of busted MRI machines. On top of that, research labs are grinding away at developing new green chemistry methods to extract and purify it with way less environmental impact. This pivot towards sustainability is absolutely essential to guarantee we've got a steady supply of holmium down the road, especially with the demand for high-tech gear that relies on it just hitting the roof. So, where is the future of holmium heading in the tech world? Scientists are constantly exploring fresh ways to use it, like packing it into the heart of quantum computers and developing materials that stay superconducting at way higher temperatures. There's also some serious research going into using holmium to level up battery efficiency and craft way better energy storage solutions. And with nanotechnology moving at warp speed, we might see holmium popping up in totally brand new applications, opening up massive possibilities for this rare element. Despite it being so rare and a nightmare to extract, holmium stays a total cornerstone for the future of tech evolution. These unique properties and innovations have honestly made it an absolute must-have in our modern digital age.